In this video, I'm going to show you how to create a real-time multiplayer blockchain game. Hi, I'm Ed Zynda, and this is What the Funk. This video is sponsored by QuickNode. QuickNode is a globally distributed network of nodes servicing hundreds of billions of API responses a month. QuickNode gives developers access to enterprise-grade infrastructure trusted by some of the largest companies in Web3. Today we're going to take the classic 4 in a row game written in Solidity and creating a UI for it. Our UI will allow players to play against each other and will update in real time as each player makes their moves. This real-time communication will be made possible by the QuickNode WebSocket RPC endpoint. Before we go any further, here at What the Funk, we cover all things Web3 and blockchain development. If that's something that you're into, please consider subscribing to this channel and clicking that bell notification icon so you can stay up to date whenever I post a new video. Let's get into it. So we're going to be building this app using the SvelteKit JavaScript framework. And to do that, we are going to need to create a new SvelteKit application. We can do this by running npm create svelte add latest and giving it the name of our project, which will be 4 in a row. We can say yes to all these prompts. We want a skeleton project. We want to be using TypeScript. We'll go ahead and add ESLint, prettier. We don't need any browser testing. We don't need any unit testing. Now we can cd into our directory and run VS Code. So now we have a project opened in VS Code, but before we go any further, I'm going to do a quick walkthrough of the smart contract we're going to be working with. This smart contract was written by a developer called Tony Warstadter. I hope I didn't pronounce that name wrong, but I basically took his code and then made a few modifications and removed some things for brevity, just so it makes it easier to work in this video. And basically it runs like the classic 4 in a row game where 2 players try to take their color circle and connect 4 in a row before the other player connects 4 in a row. So you've got your basic storage to store the different games that people are running against each other, the number of games that each person has, and then any open games. And each game has its own state, so has an ID, some players, a variable to show which player's turn it is, whether it started or ended, and also keeps track of the different pieces on the board and the last move. And there's some other variables that I kind of left in here I should have removed, but just suffice to say, this isn't a very clean and professional smart contract, so I wouldn't use this in production. I just basically took this for demonstration's sake. We've also got some events here. So event for creation, game join, game move, game end. And I also left this draw proposed, but we're not going to be using this. And then some other stuff. So the important methods we've got here are the challenge victim or challenge opponent. So basically a player can challenge another wallet address to a game. So we're going to be listening for that. This player can then accept the game or join the game. There is a method for getting the state of the board so we can see which pieces belong where. We can get the game, so which players belong to the game, whose turn it is. We've got a method for making a move and a method for checking whether or not somebody has already won the game. So when somebody makes a move, at the very end, we also check if that move has given them the win. So that's the basic gist. If you want to look into this contract a little bit further, I've got a link in the description and also a link in the repo for this UI that we're going to build. So you can have a look at that. I won't go into it much further. So the next thing we want to do is add Tailwind CSS for styling. I'm too lazy to work with vanilla CSS and I love Tailwind, so we're going to install that. And Svelte adds a very cool command that will add and bootstrap everything for us. Cool, that's installed. Next thing we want to do is install all of the dependencies for our project. I use pnpm. You can use npm or yarn if you so choose. Cool, that's installed. Now we're going to install some other dependencies for working with the blockchain. So I've got Web3W, which is a cool library for working with wallets in SvelteKit. I'm also going to install various namespace packages from the Ethers project. So I'm going to need ABI, address, big number, contracts, and providers. And finally, Daisy UI, which is a component framework that uses Tailwind under the hood, but it's also got a lot of nice built-in components, so we don't have to build those from scratch. Next, in our editor, we want to add a .env file, and this is going to hold some configuration information. So I've already deployed this contract to the Polygon Mumbai testnet, and so I've already got a contract address. And we're also going to add our QuickNode WebSocket RPC endpoint, and this is going to allow us to receive events as they happen on the blockchain and then react to those and update our UI. So here you can see the address that the smart contract is deployed to. And to get our RPC URL, all you need to do is log into your QuickNode dashboard. Here in the dashboard, you can see my various endpoints. If I go to my Matic testnet, you can see there's an HTTP provider, also a WSS provider. This is the WebSocket provider, and it's going to allow us to do real-time communication with the blockchain, and this is the one we want. So I'm going to copy that, I'll paste that here, and don't even bother trying to copy this because I will get rid of this endpoint as soon as this video is done recording. Next, we're going to create some types, and this is going to make it a little bit easier to work with our smart contract. We'll create a new folder in the source directory. We'll call it lib, and then a new file called types. First, we have the challenge, which takes a player 1, a player 2, and a game ID. Next, we have game info, which takes the same parameters, and we just create this to kind of keep things separate in our mind. And then finally, we have game state, which keeps track of the board and the pieces on the board, whose turn it is, and whether or not the game has ended. Next, we're going to create a class to represent our contract. So let's create a new folder. Let's call it contracts, and then a new file. Let's call it game.ts. So let's create a directory. Let's call it services, then a new file called game.ts. And we're also going to need the ABI in order to talk to the smart contract. And I've already grabbed that, so we'll just create a new ABI.json file, and then I'll just paste that here. Back in our game.ts file, first we want to import a few things. So we want the contract class from the contracts package, JSON RPC signer, and listener from the providers package. We also want a WebSocket provider from the providers package. We need our ABI. We want to import our types that we just recently created. And we want to import the environment variables that we created earlier. Next, let's create a class called game. At the top of our class, we're going to define a few attributes, a variable to store our ABI, a variable to store the signer, and a variable to store the contract. Next, let's create a constructor. And so this constructor is going to take a signer, and later this signer is going to come from MetaMask. And we're going to pass this signer and save that into the signer variable. We're also going to create a new provider using the WebSocket provider and the WebSocket RPC URL we got from QuickNode. And then we're going to create a contract instance using that address that we defined earlier, the ABI, and this provider we just created. Next, we need a method for challenging an opponent or challenging another address. So here, this method will take an address, and then it will call the challenge victim method on the contract that we saw earlier. And because this is going to write to the blockchain, we need to pass the signer because the user is going to need to sign this transaction in MetaMask. Once a user receives a challenge, they're going to need to be able to accept that challenge. So let's create a method for that. This method accept challenge is going to take the host address, which is the address of the person who created the challenge to begin with. And this is going to also connect the signer because the user needs to sign this. And it's going to call the join game method on the contract, passing in the address of the user that created the challenge. And in this case, we're going to actually take the transaction and then wait until it's been mined and I'll show you why later on. Next, in order for a user to be able to see a challenge if they just log in, they need to get a list of open challenges that are addressed to them. So let's create a method for that. This method is going to return an array of open challenges. First, it takes the address of the signer or the person that's currently signed in. We create a filter, which basically looks for the game creation event. And then we also create another filter for the game join event. So we need to figure out which challenges have been created and which challenges have been accepted. So we can tell a challenge has been accepted by matching up the game creation with a game join. So first, we get all of the challenges by calling query filter, and then we pass this block number. So this is the block number that the contract was actually deployed at. And the one thing about Polygon is that it only allows you to query events up to maybe 10,000 blocks in the past. So you need to kind of limit how big you're actually searching. A better way to do this is probably to hook your smart contract up to something like a subgraph to where you can query these events as they get indexed. But right now we don't have a subgraph, and we're not going to go into that for this demonstration. So once we have all of the events, we can map those into to fit the type that we created. So we'll add the player 1, player 2, and then the ID of the game for the challenge. And we can do the same with the join game filter for all the games that have already been accepted. And so here we will go ahead and filter out any games that have already been accepted and just return the ones that have not been accepted. So the smart contract actually allows you to have several different open games with several different opponents. But for the sake of this demonstration, we're only going to deal with one game at a time. We're going to define a method that gets a list of all the games that have been accepted. And we're just going to take the first one, and that's the game that's going to be displayed on the user's screen. So here, if there is at least one game that has been accepted, we will return it. If not, we'll return null. Again, we get the user's address. We call the number of games that they have set up in the contract. And then we set this open games variable to an empty array. We loop through the mapping called myGames based on the number of games that are listed in storage, and then check to see if there is a game that has been started, in other words, accepted, and also whether or not this game has not already been ended. And then we will push that into the array, and then at the very end, we'll go ahead and take the very first element of that array and return it. Next, in order to get more information about the game that's currently being played, we have a getGameState method. So this getGameState method is going to first get the board with all the pieces of the game, and then get the game based on the game ID that we pass in. And this is simply just going to add which players, and then the ID, and then whose turn it is. It will also set whether or not the game has ended. Now, in order to play the game, each player has to take a move. And so basically in this game, you deal with a series of rows and columns. So there are 7 columns and 5 rows. And to take a move, a player basically drops their piece in one of the columns, and then the piece drops all the way down until it either lands on the bottom or lands on another player's piece. So let's create a method for that. So this method takes the ID of the game that's currently being played, and then the column that the player wants to drop their piece into. And then this simply calls the takeMove method on the smart contract. And because it needs to write to the blockchain, we connect the signer. Now, in order for our UI to respond to things happening in the game, we need to subscribe to different events. And to do that, we're going to create a series of different subscription methods. First, we're going to subscribe to challenges, and this will allow us to see whether or not someone has challenged us while we are currently logged into the UI. So the only argument that it takes is this handler, and the handler is an anonymous function. And we pass this anonymous function from our UI, and this allows our UI to respond to things as they happen. So we get the address from the currently signed in user. We again create a filter based on that user's address. And then whenever this event for that filter occurs, we call this handler method. Here I've created 3 more methods, and they do exactly the same thing as the subscribe to challenges method, but in this case, this one subscribes to game start or joining a game. The next one subscribes to any player moves, and the final one subscribes to whether or not a game has ended, or in other words, a user has won the game. The final method is a cleanup method to remove these listeners. If you don't have this, you can run into problems where you have multiple instances of the same listeners, and you'll get kind of crazy things happening in your UI. So let's create that. And so here we have a remove subscriptions, and all this does is remove all of the event listeners that we created up here. Next, we want to create a way to handle game state within the UI. And a really easy way to do that is using Svelte stores. So back in our lib directory, let's create a directory called stores. The first store we're going to create is a wallet store. And this will be super easy because all we're going to do is import the Web3W library and initialize it. And so all this does is give you a bunch of stores created for free. So you've got a wallet to track the wallet, built-in flow, transactions, and chain. We probably won't use all of these, but this is what the initialization method gives you. And then you kind of configure it. So this built-in basically refers to the built-in wallet of your browser. In our case, it's going to be MetaMask. And then it auto probes, basically it auto detects what kind of wallet it is. And then the options, the only option we're gonna deal with right now is the built-in option, which is again, MetaMask. If you've installed another package, you can also do things like Wallet Connect or other wallet providers. But for the sake of this demonstration, we're only going to deal with the built-in wallet. And then we're just going to export these stores that are already created so we can access them through other parts of our application. Next, we're going to create a store for all of the different pieces of our game. Let's create a file called game. First, we're going to import the game class we just created. And we're actually going to store this in a store so it can be accessible throughout the application. And we only have one instance that everybody can use. Then we import this writable method from the Svelte store package. And this is basically how you create writable stores that you can read and write from different components and different pages in a Svelte application. And then we're going to import this challenge type. Next, we create a board, and this represents the game board that we're going to be displaying in our UI later. So we do this basically calling this writable method, giving the type of the store. So it's going to be a multi-dimensional array of numbers, and then we give it a default value. So to represent our game board, any empty area on this board is represented by 0, and then the pieces are represented by either a 1 or a 2 to denote which player's pieces are on the board. Next, we create a store to store all of our challenges, and then finally a game service store to store the instance of our game. We can set it to, initially we set it to undefined because we aren't actually able to create this until a user has signed in with MetaMask. And then finally we export everything. Now to see what everything looks like, let's go ahead and start our development environment. We can do that by running pnpm, and then we can just click on the link that it gives us. So this is the default screen you're going to get when you create a new SvelteKit project. One thing I forgot to add was the plugin for the Daisy UI framework. So let's go ahead and add that into our Tailwind CSS config. Back in our editor, let's go ahead and update this plugins section. If we save that, go back to our page, now we can see we have a little bit different colors. Daisy UI is also themable, so we can go ahead and change the theme. I'm going to use a theme called Aqua, which I kind of like the colors for. So to change the theme, you just go to the HTML tag, set the data theme property, and then the name of the theme. You can see when we go back, we have this nice blue color. And let's go ahead and get rid of this default stuff. If we go to routes and then page.svelte, we can delete this stuff right here. You can see it's empty now. So now let's create our first component. And the first thing we need to do is allow a user to sign in. So let's create a directory called components in our lib directory. Next, let's create a component called address. At the top, we'll create a script tag, and we're just going to import the wallet store from the store we created earlier. And then down below, we can add some markup to show a wallet address if the user is connected. So right now, this isn't going to work because we don't have a way for the user to connect. So let's create that now. So there's quite a bit going on here. So let me go through it step by step. First, we import our game service, and then we import the wallet store and the chain store. So we can basically call connect on our wallet and also see which chain we're connected to. We import the type for JSON RPC signer, and this is what we're going to pass to our game service, which we import down below. Next, we want a method to connect, and this is going to be called when a user pushes a button to connect. And when we connect, we're going to call the wallet.connect method with the built-in option. And then after the wallet is connected, we want to pass the instance of the signer from that wallet to a new instance of the game service. And then we set that game service to our store that can be accessed throughout the rest of the application. And then down here, we have this cool $:: syntax. And basically all this does is allow us to do reactive things with Svelte. So whenever something changes in Svelte, we can react to it using this markup. And then whatever is in this bracket section right here will happen on every change. So on every change of a variable in this component or anywhere else in the app, it's going to check if there is a chain ID that exists, and if that chain ID is 80001, which is the chain ID of the Polygon Mumbai test network. And you're only going to have a chain ID existing if the wallet is connected. So all we're doing is checking to make sure that the user is connected to the correct chain. If not, we unset the instance of our game, we disconnect the wallet, and then we set an alert window to tell the user to connect to the right blockchain. This should be Polygon Mumbai. And finally down below, we have a simple button that allows the user to connect their wallet. And so this listens to the click event of the button and then calls the connect method we defined above. So in order to see what that looks like, let's go ahead back to our plus page.svelte in our routes directory. Let's create a script tag. And real quick before I forget, in our components directory, we want to create an easy way to export our components and then import them into other pages. So let's create an index.ts file in our components directory. And here, let's import our address and our connect wallet components and export those. So now back in our page.svelte, we can import both address and connect wallet. And SvelteKit gives you this nice $ syntax for importing the lib directory. So you don't have to do a bunch of .. So we've got this $lib components, and it auto imports those using the index.ts file. Next, we want to import our wallet store because we need to see whether or not the wallet is connected. And then down below, let's create a div to hold all of our components. And then within that div, we have an if-else block that basically checks whether or not the wallet has an address. And if it does, display the address component. If not, display the connect wallet component. And if you're not familiar with Svelte, all this $ means is that we are subscribing to the store updates of this wallet store. So basically we want to listen to anytime this wallet store changes. and react to it. So now we have a connect wallet button. So now if we hit connect, it'll show our address. Next, we want to create a component to allow our user to challenge another opponent. Let's create a file called challenge opponent. First, we need a few imports. We want the game service so we can interact with the contract. And we want this isAddress utility function from the address packet. Next, we have a variable called address, and this is where we're going to store the address of the user we want to challenge. And then we create a method called challenge opponent. And this first is going to check whether or not the address we put in is a valid address. If not, it's going to let the user know. And if it is, we call the game service challenge opponent method that we created earlier. And then down below, we've got the markup, and it's basically just a form with a label for challenging the opponent. It takes an input and then binds the value of this input to the address variable we created. And then when we click the button, it calls the challenge opponent method. Let's add that to our index.ts file, import it in our page.svelte file, and then add it in our markup down below. So now when we connect, we have this form, and paste in a random address. When we hit challenge, it brings up MetaMask. But in this case, we're not going to sign it yet. We'll wait till later. Next, we want to display whether or not we've received challenges from another user. So let's create a component to show a challenge from another user. Create a new file called challenge request. And in the script tag, we import the game service, the challenges store, the challenge type, and we create a variable called challenge. And then we create a method called accept challenge. And all this does is call the challenge service accept challenge method, and then accepts the challenge of whatever wallet has challenged us. And then we call the get open challenges method and update the open challenges. And this is why we used the tx variable in our class earlier. So over here, we actually wait until the transaction is mined. And so wait until the full state of the smart contract has been updated. And then we know that we can call get open challenges down here and get the correct amount of open challenges and make sure the challenge that we just accepted no longer appears in that list. So then we set the open challenges into our challenges store right here. And in our markup, we just have an alert with the title new challenge. You have a challenge from, and then the address of the challenger, and then a button for whether or not you want to accept this challenge. And this we'll call the accept challenge method. And this SVG is just a nice little icon that you will see later on. Here we just add our challenge request component to the index.ts file. In our page.svelte, we can import challenge request, and then down below, we create a loop that basically iterates through any challenges we have and then displays a challenge request. This means we need to import the challenges from our store that we created earlier. So here we've imported from our game store, and now we need to start listening for any new challenges. So first we need to check whether or not we have an instance of our game. So we're going to use a reactive block, and we're going to check if the game service exists. If the game service exists, we're going to grab open challenges. In order to use this, we need to import the game service store. And one other thing, we only want to do this once as soon as the game service has been initialized. So let's create a variable called initialized, set it to false, check whether it's been initialized, and make that the first thing we do when we pass this check. So this will only run once. After we fetch open challenges, we want to subscribe to new challenges. So if there aren't any challenges as we initialize the game, we want to be able to show challenges as they appear in real time by listening to the blockchain. We can do that by calling the subscribe to challenges method on our service and then pass in this handler. And this handler will take 3 arguments. One is going to be the first player, the second player, and then the game ID. And then basically we are going to push this challenge and all of the parameters into the challenges store. And this will update and should show our challenges in the bottom of our screen using the component we created. So now I have two browser instances open. They're both connected. In one browser, I'm going to go ahead and challenge the other browser. If we hit challenge, it brings up MetaMask, we confirm, and after it confirms, we should see a challenge pop up in the other browser. And so now you can see that there is a new challenge, and we can accept this. We'll go ahead and do that later. Next, we want to add a way to clean up our subscriptions when this page is closed. So here we import this onDestroy method from the Svelte package, and then onDestroy we'll call the remove subscriptions method we created earlier, and this will unsubscribe to any listeners we created. So now in the case of accepting a game, we want to get the current open game. So we create a variable called game of type game info. We've imported the type up here, and then down below we call this get open game method and store the result into the game variable. So if there's a game, it will store it. If not, it will stay null. And then in the case of joining a game or someone accepting your game while you are logged in, we want to listen for that. So we can call subscribe to game start, and this works similar to subscribe to challenges, except it receives the players in a different order. So you receive player 2 first, then player 1, and then the ID. And then we check if this game start event that we just received belongs to either us or our opponent and not some other wallet. And if it does, and then we will store this information into the game right here. And so now we need to display our game board. So the first thing we're going to create is a cell or a place to hold the pieces of our game. So in a file called cell.svelte, it's simply going to hold a value, and then it's going to decide the color using a CSS class or a Tailwind class. And then the default Tailwind class is just going to be a circle of 16 by 16, and then have a black border, and it's just going to be a different color depending on the state. So if player 1 has this cell, then it's going to be red. Player 2 will be yellow, and if there is nobody there, it's just going to be kind of a gray color. So finally, let's create a board. So the board component is going to take the board store. It's going to use the onDestroy and onMount methods from Svelte. We're going to use the cell component that we just created. It needs to use the game service, the game info type, and the wallet store. This component is going to take a parameter called game. This is why this has export in front of it. And it's just going to be the game info that we get from the main page. We're going to have a variable that keeps track of whose turn it is. By default, player 2 usually starts. And then my player is basically which player the current user is. So this is going to decide whether we're player 1 or player 2, and then decide whether or not ended is false. Here we have a take move method, and this just takes a move. Next, we have a method to update the state of the board. So we're going to call this anytime the state of any of our stores change, or somebody's made a move, or we received a new event. So basically it's going to call the game service, get the current state from the blockchain, check whether or not the game has ended, and then basically set the new state of the board into our store, and also change the turn of whoever's playing. We call this onMount method, and this is called anytime the component comes into view. So we know this component's only going to come into view when we're signed in and we actually have a game running. So it's completely safe to call it. So the first thing we're going to do is update the board, and then we're going to subscribe to a few events using our service. So we're going to subscribe to any new moves. If there's a new move, we want to update the board, and then we're going to subscribe to the game end event. So if the game has ended, we display an alert showing that the game has ended. And then again, we want to clean up any subscriptions that we have when this component goes out of focus. So in our markup, we want to check whether or not the game has ended or not. If it hasn't ended, we want to display a little bit of information about our player. So we're going to display our color, whether or not we're red or yellow. And then we want to display whose turn it is. If the game is ended, we want to display game over. And then finally, we want to display the board itself and then some buttons to actually make moves. So here we also check again if the game has ended. And then we do basically a for loop 7 times, representing the 7 columns of the game. And these buttons will basically, if a user clicks the button, it will basically make a move on that column. We also want to disable this button if the number of pieces has already reached the very top of the board, so we won't be able to make any more moves. And then finally, we've got nested for loops, basically looping through each column and each row. And then we kind of invert the array that we actually have stored, because the way arrays are represented in code are different than how we want to represent it on the game. So it's kind of flipped. And you can do this by taking the number of rows and then subtracting the current row index from it, and then it'll invert it like this. Again, we add our component to index.ts so we can import it from our main page. At the top of our page, let's import board. And down at the very bottom, if there is a game in play, we can show this board component and pass the game as a parameter. So back in our game, let's go ahead and accept this challenge. We'll sign this transaction. And as you can see, the game board shows up and it's the person who's accepted's turn. And we are yellow, so let's go ahead and make a move, sign the transaction, and it shows up on both screens. If we play on the other side, sign the transaction, it shows up on both screens. Now let me speed this up all the way to the very end. All right, we're at the final play. Obviously, nobody would actually play like this. There'd be a little more strategy involved, but in this case, I'm just going to place the final piece for yellow over here, sign the transaction. And as you can see, you see an alert message saying the game is over. If you hit OK, shows the final state of the game and game over. And that's it. That's how you create a real-time multiplayer game on the blockchain using QuickNode's WebSocket RPC endpoints and the Polygon blockchain. If you enjoyed this video, make sure to smash that like button. If you have any comments or questions, leave them down below. Once again, thanks for watching, and I'll see you in the next video.